For this video, we are going to learn another method to find out the probability, where we know it as probability trees, or some reference book will call it as tree diagram. Right, so generally for me, I think this is actually a method that is widely used in a lot of questions. All right, so actually, when are we going to use this method? Generally, when your question involves sequence or process, or when they are conditional, or when they are independent, the tree diagram will be very helpful in solving these questions. All right, so generally you will see that we are having different branches from every single event, and there are a few important things that you need to know. The first one is the total probability of the branches from the same beginning. All right, when you total them up, it should be equals to 1. So which means PA plus PA prime, it should be equals to 1. If let's say when you total them up, it is not equals to 1, that means something wrong with your tree diagram. All right, then the same thing happens if let's say you're having the next probability. So if you take this probability plus this probability, because they are from the same beginning, right? So this probability plus this probability, you should have the total also equals to 1, and so on. All right. Okay, then this is the first important thing that you need to know lah. And then for the second thing is, when you are drawing the tree diagram, it is not necessarily that every time you are having two branches, a pair of branches. All right, some question might have 3. Some question might have more than 3, or maybe only 2. All right, so it depends on the structure of the question. All right, so the first important thing that you need to know to use this tree diagram is you have to draw a correct tree diagram with all the correct probability. Then only the tree diagram method will be useful for you to answer the question. All right, so let's have a look and go through with a few examples. How are we going to apply tree diagram in our question? Right, so you can have a look for example 15. All right, so for this question, you're having 8 balls in total, 5 yellow and 3 red, and then a ball is drawn at random without replacement. So this is an important keyword that you need to know. Another draw is made. By drawing the tree diagram, find the probability that both balls are red, the balls are not the same color. All right, so if you look at this question, you are actually taking out 2 balls. The first one after you take out, and then followed by the second one. All right, okay, so it is actually a process. Take out the first ball followed by the second ball, so it is actually a process. Therefore, it will be quite suitable for you to apply tree diagram here. All right, so when you draw the tree diagram, we are drawing it in this way lah. So the first one is the first ball that you draw. Okay, so when you draw the first ball, it can be either yellow or it can be either red color. All right, so after you take out the first ball, then you need to list out the possible outcome for the second ball that you draw. All right, so for the second ball, you might also have the yellow, red color, yellow and red color. All right, so we'll stop our tree diagram here because we only draw 2 balls up. Then the next one will be more important. You need to put in all the probability on the branches. So we focus on the first ball first. Okay, so when you are taking out the first ball, the probability of getting a yellow ball is 5 out of 8. Therefore, the probability for this is 5 over 8. And then you are having 3 over 8 for the red color ball. All right, so you can imagine you're having yellow, you're having red. At first, you're having 5 yellow and 3 red. Okay, then now you want to fill in this value, the probability for this value. given that the first ball drawn is yellow color, that means yellow color now remain 4 only, and the total is only 7. Alright, so the second ball, if you get the second ball which is yellow color again, then the total will become 4 over 7. Then the same thing happen for a red color, it will be 3 over 7. In the other way round, if let's say the first ball that you take out is yellow or is red color, therefore the red color become 2 for now. So to get the probability for yellow color is 5 over 7, and to get the probability for red color will be 2 over 7. So all the value for this probability are very important. You have to make sure that you fill in correctly, then only your calculation for the probability later will be correct. Alright, so let's start with part number 1. They want you to calculate the probability that both are red. To get the probability for both balls are red, you generally can go through the path from your tree diagram from the beginning. Alright, so you're having first ball is red color, second ball is also red color. This is the only path that we have, both are red color. Therefore, to get the probability, you multiply them. So it should be 3 over 8 multiplied with 2 over 7. And therefore, you will get a probability which is 3 over 28. Alright, so this is how you apply the tree diagram. So you can see that if let's say you fill in the value for all the probability here wrongly, that means your final answer will be definitely wrong as well. Okay, right, and now we go to part number 2. Alright, so for part number 2, the balls are not of the same color. So they want to have the ball which is not from the same color. Alright, so how can we actually find it out? So again, you can find out the path from the tree diagram and see which fulfill what they want here. So they want both are not the same color. So that means if let's say the first ball I get is yellow, the second ball that I want to get should be red. So this is the first pathway that we have from the tree diagram. Alright, so how about if let's say the first ball that I get is a red color, and the second ball that I want to get definitely should be yellow color. So the green color part here is actually the second pathway that I have. Alright, so both pathway here actually fulfill the question. Both balls are not the same color. Alright, so to calculate the probability again, you start from beginning of the pathway. So it is 5 over 8 multiplied with 3 over 7. So this is the first pathway, which is the first complete case. And then you're having the second pathway or second case, then you need to add them together. So for the second case is 3 over 8. Then multiply with 5 over 7. And from here, you'll get the probability 15 over 28. Or you have 0.536. Alright, so this is how we apply the tree diagram in our question. Alright, then when you want to use tree diagram in any question, generally there's a very small rule that you need to remember always. Alright, so to explain this simple rule, I will want you to answer extra example here. Okay, so I want you to answer this question as extra example to take note on the rules for the tree diagram. Alright, so let's say I want you to calculate the probability that the second ball is yellow. Alright, so we talk about the second ball is yellow. Maybe some students, they will actually focus on the probability for second ball. So second ball is yellow, that means they will consider this probability, which is yellow, and also this probability, which is yellow. If you add these two probability together, you will get the wrong answer. Alright, so why is it wrong? So it related to the rules that you need to know in tree diagram. Alright, so now when the question asks you about the second ball, or maybe the event on the second branches, the second layer of the tree diagram, generally you cannot start to calculate the probability from the second part. No matter what they want, you still need to calculate the probability from the beginning. So for this example, when they are asking for the second ball is yellow, you need to start from beginning again. Regardless to the first ball, what is the color for the first ball, you need to focus on the second ball is a yellow pathway. So that means this is the complete pathway that you should have for part number 3, and you have another pathway is this one. So these two pathway belongs to the event that the second ball is yellow. So no matter how, the small rule of this tree diagram tells you that to get the probability, you must always start from the beginning of the tree diagram. You cannot start it from the middle or the second layer of the tree diagram. Right? Okay, so if you want to calculate the probability for this one, according to the tree diagram, you're having 5 over 8, 4 over 7, plus 3 over 8, and also 5 over 7. So when you add them together, definitely you will get answer. Alright, so hopefully by using this extra example, you will know that there's a small rules here that you need to know for tree diagram. Right? Okay, so this is what you have for example 15. If we have a look for example 16, you will realize that the question is almost the same like example 15. Okay, but I still want you to highlight the keyword here. For example 15, you are having without replacement, but for example 16, you are having the replacement. Okay, I mean after you take out a ball, you'll replace it back into the bag. Then after that, you take out the second ball again. Alright, so generally, the tree diagram that you draw is still almost the same, like what you have in example 15. You're having the first ball, yellow and red. After that, for the second ball, also yellow and red. The difference now is the probability given in the question, and also that you need to draw in the tree diagram. Right, so for the first ball, when you take out the yellow is 5 over 8. To take out the red ball is 3 over 8. And after that, you put back the ball that you get and before you take out the second ball. Alright, so that means the probability for the second ball, again, the yellow will still be the same, which is 5 over 8. And for red is 3 over 8. Same thing happened for the other case. And after that, they want to calculate the probability for both balls are red and then the balls are not of the same color. Alright, so for these two examples, I will just leave it for you to solve it yourself. The first part answer is 9 over 64, and also the answer for the second part is 15 over 32. So please spend some time to complete these two questions. Right? Okay, then now we can proceed to the next example. Example 17. Alright, so example 17 is a very long question. It's long. Okay, so at the zoo, 3 rides are offered. Alright, so Ravi has money for only one ride now. So to decide which ride to choose, he toss a fair coin twice. So toss a fair coin twice. So if he gets two head, then he will go on elephant ride. If he got two tail, then he will go on a camel ride. And if he get one head, one tail, then he will go on jungle tractor. So first question is they actually want you to find out the probability for each ride. Okay, so let us start with elephant ride first. Alright, so for elephant ride, okay, so as a probability for him to go on elephant ride. So to go on elephant ride, he need to get two heads. Alright, so when you're throwing two coins, generally the results are not affecting each other, so they are independent events. Alright, so to get two head, first coin you get a head is 1/2. Second coin you get a head is also 1/2. And that's why you're having 1/4 for elephant ride. The same thing happened for camel ride. To go for a camel ride, we need to have two tails. So first coin I get a tail is 1/2. The second coin I get a tail is also 1/2. And therefore the probability to go on a camel ride is 1/4 as well. Then for the third one will be jungle tractor. To go for a jungle tractor ride, you get one head or one tail. Right, so the probability for me to get the head is 1/2, one tail is 1/2, plus another one is one tail and also one head. So if you are not so sure, maybe you can list out your steps here. So this one is head and one tail, and this one is for one tail and one head. Alright, so when you total that out, you will be 1/2. Alright, so we completed the first part here. Alright, then now if we proceed further, the probability that Ravi is frightened on each of the rides are as follows. So these are actually the probability that Ravi is frightened when he gets on elephant ride, 6/10. When he gets on camel ride and he feels frightened is 7/10, and so on. Alright, so now they actually want you to draw a fully labeled tree diagram showing the rides that Ravi could take and whether or not he is getting frightened. Right. Okay, so again, if you imagine the whole question here, generally it is also a process. That means Ravi gets on a ride first, and after that they want to investigate and see whether he's frightened or not. Alright, so again, I can draw a tree diagram to help me. So different from the tree diagram that we draw before, for this tree diagram, the first layer of the tree diagram, we're having three branches. So you're having elephant, camel, and of course jungle tractor. Alright, so after you get on the elephant ride, either you get frightened or non-frightened. Same thing happens for camel, frightened, non-frightened, and also the jungle tractor, frightened and not frightened. Alright, so maybe before I show you all the outcome, maybe you can pause the video for a while and then you try to complete the tree diagram first before you continue with the answer. Alright, okay, so I want to continue for now. For elephant, the probability that we get just now is 1/4. Camel is also 1/4. Jungle tractor is 1/2. So if you total these three probability together, you will see that, oh, alright, they are equals to 1. So that means you are having a higher chance to get this question correctly. Alright, and then we go to the frightened part. When he gets on the elephant ride, he gets frightened is 6/10. Therefore, you should put 6/10 here. And because of the rules that we learned before, the total for the branches is equals to 1. So if I know that this is 6 over 10, therefore I should know also not getting frightened is 4 over 10. Simply happen for the camel ride and also the jungle tractor. Alright, so this is what we have for the complete tree diagram for this question. Alright, then next for part number 3. Ravi goes on the ride and they want you to find the probability that he is frightened. Alright, so this question is very simple. They want to know whether he is frightened or not. Alright, so again, like what I told you just now, you cannot start the only focus on the probability from the second layer of the tree diagram. Therefore, you need to start from the beginning. So the first one, if you get on an elephant ride and get frightened, this is the first pathway. The second pathway will be when you get on the camel ride and you get frightened. And you are having the third one for now, which is you go on a jungle tractor and also get frightened. So all this has the outcome of frightened, right? Okay, so to calculate the probability, I will just leave it for you for the steps here, since you're having 3 different pathways. Alright, so try and see whether you can get the correct answer or not, which is 29 over 40. Or you change it become decimal places or 3 significant figure, it will be 0.725. Alright, so I think this question is not hard, so I think you can complete it yourself. Try to write out the complete steps here. Right? Okay, then now we continue to part number 4. Okay, so for part number 4, given that, okay, so I want you to again highlight the keyword given that. So once you see the keyword given that again, you know that it is belongs to conditional probability. Alright, so you write out the special symbol first. Given that Ravi is not frightened, so not frightened should be on the right hand side. Find the probability that he went on a camel ride. So I'm having a camel ride here. Right, so this is a conditional probability that they want us to find out. Okay, so now, because we are not using two-way table for this question, we are using tree diagram. Therefore, you have to apply the formula for conditional probability. Alright, so the formula for conditional probability is camel intersect with not frightened divided by the probability of not getting frightened. Alright, so camel intersect with frightened. If you look at your pathway here, camel intersect with not frightened. So this is a probability. Therefore, in your calculation, you have 1 over 4 divided by 3 over 10 over not getting frightened. So not getting frightened, you can take the shortcut, which is 1 minus 29 over 40. Alright, so this part, not getting frightened, is actually from here. It's the complement event, okay, for getting frightened, right? Therefore, you can straight away take 1, the total, minus 29 over 40. So this is what we have for our conditional probability in this example. So if you simplify this question, you should be able to get 3 over 11. Alright, so this is another example that we actually use the conditional probability formula to get the answer without using two-way table. Alright. Okay, then now we proceed to the last example for the tree diagram. Okay, so for this example, they already give you a tree diagram, and they want you to use this tree diagram and answer the question later. Alright, so now from here you know that Hank goes swimming on any day is 0.2. So in the tree diagram, they already list out clearly for you the probability is 0.2. So at the same time, you should know what is the probability for the other branch, which that he does not go to swimming. It will be 0.8. Alright, and after that, the on a day when he goes swimming, the probability that Hank has burger for supper is 0.75. So again, they already written out the probability for you here. So that means automatically you should know not having burger after he goes swimming will be 0.25. So that the total of this branch is equals to 1. Alright, so the last information given is the x here, and therefore you should know that this is 1 minus x. Alright, so you try to complete everything in the tree diagram before you answer the question that they want. Alright, so for first part, they ask you to find the x. Okay, so before you find the x, you need useful information. So the useful information is given in the question here. So you'll see that the probability that Hank has burger for supper on any day is 0.5. So this information tells you that the probability that Hank has burger is equals to 0.5. So again, from this tree diagram, where do I have the outcome of having burger? So go swimming, having burger, this is the first pathway. And after that, does not go swimming, but have burger is the second pathway here. So when you calculate this probability is 0.2 multiplied with 0.75 plus 0.8 multiplied with x, it is equals to 0.5. So from the equation that you form here, it will not be hard for you to get the probability for x. So please complete this example yourself and try to get the value for x, which is 0.4375. Alright, then for the second part, they're asking for another probability given that. So highlight the word given that again. This tells you that this question is conditional probability again. Alright, so try to write the special symbol. They tell you that, okay, so Hank has burger for supper. What is the probability that he went swimming on that day? Alright, so again, this is a conditional probability. Therefore, you need to apply the formula for conditional probability. And if you apply it correctly, try and see whether you get the answer 0.3 or not. Alright, so after discussing so many examples here, I hope that you have the idea how to apply tree diagram in solving question. Alright, so in general, for tree diagram, it is actually a widely used method. Alright, okay, so please make sure that you know all the details about this method. Okay.